So you mentioned previously different requirements within Document-E for new build and for conversion. So is there a different approach you take to when you're designing and specifying acoustic systems for new build and for conversion properties?
From a new build design, obviously there's no building there. So it's very much a desk-based design, with architects' drawings and all their sections, elevations, their proposed details. You can work from the details and provide appropriate floor and wall constructions and junction details, so how the floor links with the external wall, with the separating wall, with the internal wall. So that blank canvas to start from, and you can get all the junctions right. From a conversion perspective, you've got an existing building. And the biggest problem with an existing building is actually knowing your starting point, knowing what's there. If you're converting a building into a number of flats, you could have some existing constructions that would already meet the requirements. In certain cases, if it's possible, you might try and test some elements before you construct or before you specify to know your starting point.
Maybe a common misconception is that it's a lot easier to pass a sound test on a new build because, as you say, you're designing it from scratch. But the change in the fabric of buildings and building materials has really changed the way that sound travels within a building over the years, would you not say?
Within new builds, the drive has been for lightweight building materials. Old housing stock and old buildings, everything was all high mass and heavy. And I think the best example we can use is external walls, 9-inch brick walls, solid walls,
brick.
Lots of mass. Whereas in new builds, typically we're building out of, we've got all the thermal requirements of Part L, and the designers are encouraged to use lightweight blockwork. Though our new builds have to achieve higher standards, for example, as an airborne result of 45 dB DNTW plus CTR, and our conversions have a 2 dB relaxation to 43, the actual starting point in a lot of cases with the high mass solid walls is much more beneficial.